I don't understand any of these physics questions. Momentum is so hard.
Hey Brianna, what you up to?
Hey Emily, how'd you get into my house?
The window is open.
Cool. Well, can you help me with these physics questions?
Well, which part don't you get?
None of it.
Well, we can start with the simplest, which is probably impulse. Impulse is a force applied in a short period of time, and the formula is F delta T equals delta P.
What does that mean?
I think I could show you better than I could tell you.
Wow, the soccer video is pretty cool, but what does it have to do with impulse?
It has everything to do with impulse. Here, let me show you. You see, the person kicking the ball. When he kicks the ball, he's applying a force onto the ball for a short period of time, which is pretty much the definition of impulse. For the formula,
What does that have to do with the formula?
well, let's look at it this way. The formula, F delta T equals delta P.
But wait, what's F?
F is the amount of force the player applies to the ball when kicking it.
Oh, okay. Well, what's delta T?
Delta T is the amount of time the player applies force onto the ball, which isn't very long.
And all that together equals delta P? What's delta P?
Delta P is a change of momentum, otherwise known as the impulse. So let's take this player as an example. Let's say he kicks the ball with 500 newtons of force for a time of 0.1 seconds, which is, if you wanted to find the impulse of delta P, you would multiply them. So 500 newtons times 0.1 seconds is 75 newtons a second.
Oh, okay. I think I understand now. Thanks, Emily.
No problem.
If impulse is a change in momentum, what's momentum?
Momentum?
Josh, how did you get here?
Chimney. Okay, look. Momentum is the mass of an object times the speed it's going at. So P equals mv.
What do all those letters mean?
Here, let me show you.
So, playing catch is fun and all, but what does it have to do with momentum?
This is momentum. P equals mv.
What do all those letters mean?
Well, the momentum of the ball, P, is equal to the mass of the ball times the speed you're throwing it at.
Okay.
Okay. If the mass is 2 kilograms and we're throwing it at 5 meters a second, then the momentum of the ball would be 5 times 2, which is 10.
Okay, I think I understand now.
And make sure to write that in kilograms times meters a second. And don't forget sig figs.
These conservation of momentum questions are so hard. I don't understand. How did you guys get here?
Don't even worry about it, Brianna.
So, what are you guys doing here?
Well, we heard that Emily and Josh were helping you with physics, and we guessed that you would need help with conservation of momentum next. And we were right.
So, what are you guys doing with those exercise balls?
We'll show you.
So, why are they set up this way?
Well, conservation of momentum is pretty much the momentum before the collision is pretty much the same as after the collision.
Meaning that if we have these two balls that weigh the exact same, 5 kilograms, and I already kicked this ball, so it would be 10 meters per second, it would collide with this ball, the momentum would never change, so this ball would be 10 meters per second. Do you kind of get it?
I still don't really understand.
Here, watch this.
Now I understand conservation of momentum, but I still don't understand elastic collisions.
Well, elastic collisions relate directly to conservation of momentum. The momentum of the first ball plus the momentum of the second ball before the collision will equal to the momentum of the first ball plus the momentum of the second ball after the collision. So if we use our formula of momentum, the mass times velocity of the first ball
Plus the mass and the velocity of the second ball.
before the collision will be the same after.
Wait, I still don't understand. Can you show me?
Here we have our formula, and if we plug in mass 1, which would be Taha plus a ball, 70 kilograms, going at around 4 meters per second, plus the second mass, Arnold of the ball, 65 kilograms, at rest, which is 0 meters per second, equals, and then we could plug in both masses because mass never changes, and Arnold after the collision is at 4 meters per second, then we proceed to solve for Taha's velocity after, which would be 0.07 meters.
So, what about inelastic collisions?
Well, inelastic collision is when an object collides and sticks together with another. The mass times velocity of the first object plus mass times velocity of the second object will equal to the total mass times total velocity.
Wow, can you show me?
Sure.
Here we have our formula, and if we plug in the mass of the ball, 5 kilograms times 5 meters per second, plus Taha's weight at 0 meters per second, we can proceed to solve for total velocity after of 0.33 meters per second.
3 weeks later.
Mr. Mark, can we get our test results back?
Oh yeah. All electronics and toys and food over there on the table.
1 eternity later.
Okay. Brianna Parks. Wait. Well, good job, Brianna. I see that you didn't play video games or watch the Canucks lose.
Wow, 100%. Oh boy.
Wow, good job, Brianna!
Hey, Mr. McCullers, over at club for you.
One last thing. Can I go to the washroom?
I'm just too nice. I give you 50-50 chance. Heads or tails?
Heads.